Okay, so last week we talked a lot about adding and subtracting radicals. We even got into a little bit of multiplying radicals. Today we're going to look at how do we divide radicals. So for example, let's say that we have the square root of 10 divided by the square root of 3. And I know, yes, you could plug in a calculator and you get some decimal out. But we're going to look at, let's try to put this in what we call simplest form. So the first thing that when we look at this, we never like having radicals in the denominator. So we don't like that square root of 3 there. Um, so to get rid of that, we're going to multiply by we're going to multiply here by what I call a convenient form of 1. Or in other words, we're going to have the same thing on top as on bottom. Just like you might say, oh, well, 6 over 6 is 1. Anything divided by it itself is 1. So in this case, we're going to take this exact same term we had in our denominator, and that's going to go on both the top and the bottom. Okay, so it's our convenient form of 1 here in parentheses. Once we do that, we have to remember, well, when we multiply fractions, we're going to multiply the numerator times the numerator, and then the denominator times the denominator. So we'll end up with the square root of 10 times the square root of 3 over the square root of 3 times the square root of 3. If we look at this, we go, okay, well, this kind of looks like when we multiplied radicals on top. If you have two radicals, as long as they have the same index, since they're both square roots, we can put them under one radical here, okay? And we can do the same thing on the bottom. So I just did 10 times 3, okay? On the bottom, we can do the square root of 3 times 3, or 9, okay? And the denominator here simplifies very nicely into 3. And on top, we still have the square root of 30. And so we have to ask ourselves, do any of our perfect squares, just to remind ourselves our perfect squares, 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so forth. Are any of these numbers, are they factors of 30? And if we look at it, we go, well, 4 doesn't work, 9 doesn't work, 16 doesn't work, 25, no. And then after that, you're too big. So this would be your final answer. Okay, the square root of 30 over 3. Okay. Let's take a look at just one more. Let's give ourselves a little more room. Let's take a look at one more example just to kind of cement that process. Okay. This time, we're going to say it's 5 divided by the cube root of 32. Now, this is a little different because we don't have a radical here on top. It's just a whole number, 5. Um, but the process is exactly the same. We're going to multiply, okay? We're going to multiply here, and we want it to be a convenient form of 1, okay? Now, this one is actually a little trickier, okay? Um, I'm gonna put on bottom. I know last time, since it was a square root, we put a square root. If it's a cube root, we're actually gonna put, so we wanna have 3 cube roots. We're actually gonna do it twice. We wanna have 3 cube roots of 32. And I can explain why. If you guys know that if we do x squared times x, it'd be x a third. You just did 2 times 1 here. Or 2 plus 1. Sorry, 2 plus 1 here. This 32 up here, this 32, the cube root of 32, that is really 32 to the 1/3 power. So if we do it 3 times, 32 to the 1/3, we do all 3 of them, 32 to the 1/3. Once we add these up, we're going to have 1, 2, 3 thirds. So this would be 32 to the 3/3, or 1. Okay, so that's why we had to do it twice there. Or we had to have 2. All right. And again, just like our example before, we have to have the same thing on top and on bottom. Okay. I'll switch colors here. All right. Well, on the bottom, we just said that we're going to have 32 to the 3/3 or 32 to the first power, or just regular 32. On top, we're going to have 5 times the cube root of 32. That's this guy. Times the cube root of 32. Okay. Um, just like before, if two radicals have the same index, all right, we can write that as a multiplication statement underneath the radical. So 32 times 32, okay, all over 32 here. All right, I know we have a lot of 32s going on. 32 times 32, I don't know that off the top of my head. Well, we can plug it into a calculator. And we get 1,024. So we'd have 5 times the cube root of 1,024 over 32. Well, let's see if we can figure on. I don't know what the cube root of 1,024 is off the top of my head. So let's just plug it into a calculator and see what we get out. Turns out it's some kind of ugly little number. So we're going to leave this as our final answer in this case.